Lesson 2J, How to Draw Lewis Diagrams of Molecular Compounds. First, we'll look at Bohr diagrams of covalent compounds. Remember, covalent compounds are sharing valence shell electrons. Our first example will be Co2 Carbon Dioxide. As indicated by the compound's name, it consists of 1 carbon and 2 oxygens. Carbon is element 6 and has 2 electrons in the inner K shell and 4 electrons in its outermost shell or valence shell, the L shell. Oxygen is element number 8 and has 2 electrons in its inner K shell and 6 in its outermost L shell. Here's the second oxygen atom. For each atom, you can see that the valence shell is not completely filled. Since the elements are nonmetals, neither carbon nor oxygen will give away electrons. Nonmetals only acquire electrons. In this case, to fill the valence shell of the right side oxygen, carbon will share 2 of its valence shell electrons, and in turn, oxygen will also share 2 valence shell electrons. This means that they are sharing between the 2 atoms 4 electrons in total. If we now count oxygen's valence shell electrons, we see that it has 1, 2, 3, 4, 5, 6 of its own blue electrons, and 7, 8 if we count the 2 red ones that oxygen is sharing. This means that its valence shell, the L shell, is now full of electrons. It has 8 electrons. This is called the Octet Rule, where we try to fill a valence shell to 8 electrons when building covalent compounds. If we look at the carbon atom, it has 1, 2, 3, 4 of its own red electrons, and 5, 6 if we count the 2 shared from the right side carbon. To complete its valence shell and fulfill the octet law, we will need the left side oxygen to share 2 of its valence shell electrons. Now we can see that the central atom has 1, 2, 3, 4 of its own valence shell electrons in red, and 5, 6 if we count the blue electrons from the right side oxygen, and 7, 8 if we count the 2 from the left side oxygen. The left side oxygen also has a full valence shell. If we count the total number of valence shell electrons for all 3 atoms, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. In the Lewis diagram, also known as the structural diagram, we only show the valence shell electrons as the inner shells are not involved in the bonding. And for each pair of electrons, we can draw a straight line. In between the carbon and oxygen, we see 2 pairs shared here and here. And then we see a pair on top of the left oxygen and below. On the right side oxygen, we see the same, a pair on top and below. This is the Lewis diagram, or the structural diagram, of carbon dioxide. The black bonds are the covalent bonds. In this case, each is a double covalent bond, a double bond. And the white pairs not involved in the bond are called lone pairs. There is a total of 4 lone pairs. Sulfur monoxide has a single sulfur and a single oxygen. Sulfur has 6 valence shell electrons, as so does oxygen. To fulfill the octet rule, they will share 2 electrons each, creating a double bond. The simplified view would be this with a double bond in between and a total of 4 lone pairs. Sulfur dichloride has 1 sulfur and 2 chlorines. Sulfur has 6 valence shell electrons, while chlorine each has 7 valence shell electrons. To fulfill the octet rule, each chlorine will share an electron with the sulfur atom. Redrawing it, we get this diagram where there are 2 single bonds and a total of 1, 2, 3, 4, 5, 6, 7, 8 lone pairs.